On 6.2, we look at the law of cosines. Law of cosines is when you have either side angle side, so you have two sides in the angle in between them. That might be like, let's say if we knew that this was 15 and we knew that A was 18. And we knew that this angle was 97 degrees. Okay, that would be a side angle side case where we would use law of cosines. Or if you have side, side, side. So if we knew the three sides of the triangle but didn't know any of the angles, we can also use law of cosines. And the key, the only difference in these three formulas down here is where you have your A's, B's, and C's. And the key, at least in my brain, is always this. That wherever either the angle you're looking for, so if you have all three sides and you're missing an angle, you got to pick an angle to look for first. That's the angle that goes over here, and whatever side is across from it, that's the side you put on the other end. Inside the formula, it doesn't matter if you do a squared first or c squared first. It's always a 2 here times a times c. The key is that you get the opposites on the opposite end of the formula. And then the only other warning I would say is if you're starting with, if you have side, 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 find the biggest angle first. If you do the biggest angle first, you will avoid the ambiguous case, and we want to do that if we can. So all we're really going to do is go through two quick examples so you have kind of a starting point. We're just going to find one piece of each of these triangles. The nice thing about law of cosines is you usually only have to do it once. And then if you do the law of cosines once and get that answer, either that side or that angle you're looking for the rest of the problem you can use law of sines and our other little triangle tricks. So over here we're looking for A in this triangle. So in my law of cosines formula, A squared is what I need on the left. And then it doesn't really matter whether you put the 20 squared first or the 30 squared, but we should have 20 squared plus 30 squared minus 2 times 20 times 30 times the cosine of 60. And the nice thing about these problems is if I have a squared over here, I can type this all in one straight shot. And in fact, I really recommend you do that. We have to be really careful with the order of operations here. And when people start splitting that into different pieces, that's where they make mistakes. So I'm just typing in 20 squared plus 30 squared minus 2 times 20 times 30 times the cosine of 60. Make sure you are, in fact, in degrees. And then what I end up with is that a squared equals 700. But I don't want a squared, I want a. So a is just the square root of 700, which is 26.5. And then once we know that a is 26.5, if I needed to solve the rest of the triangle, I could do law of sines. I could do sine of 60 over 26.5 equals sine of c over 30. And I could do sine of 60 over 26.5 equals sine of b over 20, and I could finish the triangle. So that's one kind when you deal with side angle side. The option is what if we have side, side, side. And this triangle in particular, they specifically asked you for the biggest angle first. But even if you were solving the whole triangle, you should look at the three sides you have and find the biggest angle, which is going to be across from the biggest side. Do that one first, and you'll avoid the ambiguous case. So when I'm looking for an angle, we need to be a little more careful. The setup is similar. This is the side across from my angle, so that's the one I want all by itself, 9 squared. Then it doesn't matter which order you do these in. I can do alphabetical though. So it'd be 6 squared plus 4 squared minus 2 times 6 times 4 times the cosine of b. Here's where we need to be careful. People make a really common mistake, And to help you avoid that mistake, here would be my advice for how to proceed from this. My goal is to solve for the cosine of b. So before I do anything else, I would actually subtract minus 6 squared minus 4. Oops. I would subtract the 6 squared and the 4 squared right away from both sides. So over here, I'm going to type in 9 squared minus 6 squared minus 4 squared. And then over here, I'm still going to have that negative 2 times 6 times 4. If you just always do it that way, you will avoid a very common and annoying problem that gets you the wrong answer. So then if I type this in, 9 squared minus 6 squared minus 4 squared, I get 29 on this side, equals negative, and when I type in 2 times 6 times 4, I end up with 48 cosine b. So I'm solving for cosine b. I need to divide by that negative 48. And now I end up with cosine b on one side equals that negative 29 over 48. Well, that's what I'm going to take to get, I'm actually looking for an angle here, so I'm going to need, my actual angle is going to be the inverse cosine of that fraction. And if we type that in, inverse cosine of negative 29 over 48 is 127.2 degrees. So it is okay if that decimal is negative, that can happen, and with big angles it will. And then just like last problem, if you were going to go on from here, now I know how long or how big this angle is, so now I could do sine of that 127.2 divided by 9 equals the sine of a over 6, let's say. So it's really just the first step that becomes different when you're dealing with law of cosines. So that'll wrap it up for examples. Hopefully that gets you at least started. Just please be sure to ask questions if you need help.